Hello everybody, welcome back to ZWF repair, and this time we have Commodore disk drive 1541. This is the C version, which is the white case and reduced electronic board. And this is in a quite sorry state. This has been punctured sometimes, and here there is missing paint. Mechanism is very stiff, but we'll see later. And it has a modification, which is probably the spindle that I have on another drive. Oh no, this is actually, it says Dolphin DOS. I've never seen it. Let's see. Anyway, I don't think I will maintain this modification. I will revert to just try to original, because it makes no sense to me to have a modified drive. I have my own from the 80s, and anyway I don't have any other modified C64 with Dolphin DOS more. So we'll see. Let's crack it open. Okay, first of all, the inside appears quite dirty. It may be from a smoker owner, I don't know, but I will clean all the case with dish soap. Also, I will remove this part of the mechanics and electronics and wash also the other part of the case. This switch added on the front panel probably goes to switch back the original ROM, which is still in its place. And this Dolphin DOS has the other board. Well, the speed DOS that I had, it's only a kernel replacement for the drive, and parallel cable hooked on one of the 6522s, which in this modification reside on its own board. They added also 8 kilobytes of RAM to the disk, more than four times that the original RAM. Well, that's very good, but a bit useless if you don't have Commodore 64 modified to use it. So let's another thing that you can notice is that the front bezel of the drive was the black one of the original 1541 that has been painted later. Probably the original one was broken and they painted the black one. So I might also repaint it. It's better than leaving on two different colors. Okay, all the mechanical and electronic assembly can be removed from the bottom half of the case by removing 6 screws. 1, 2, 3, 4, 5 and 6, and by removing the connector that connects the power LED, because the power LEDs can be removed from the case anyway if you really want, but in this case I'm not sure I will remove the LED. I will just need to wash the whole case, and I will wait a few days to dry, so no water can go inside an LED anyway. Yes, definitely this unit was owned by a smoker, and I can also smell the substance and in here. So I will clean this part with alcohol before proceeding. And on the outside, the bottom side, I mean, it seems all quite okay. There's some rust, but overall it's satisfactory conditions. On the 1541C, the electronic board can be removed by unplugging this connector, removing the screws, removing these two screws. Then the electronic board can be set aside and we can access the power transformer. What we see inside here is that this power transformer has 3 posts and 2 are connected to the mains and 1 is free, so we need to determine what is the correct configuration for 240 volts. When I work with mains equipment, we're not using insulation transformer. I use the clips connected firmly where I want to take the measurement. When everything is unplugged, I set the multimeter to the range that I want to use. Then I will connect the power cord, turn on. With this disconnected, the electronic won't be powered, only the transformer to see where the correct posts are. So I powered, and with the posts in this position, I measure the mains voltage, which is 238 at the moment, so almost 240, which is a bit high here, but it's well within what we can expect. And now I have to determine what wire I have to move to set the primary for this transformer to 240 volts. Okay, now measuring between the first contact, the black, where the black wire is connected, and the last one, I measured 260. So I have a higher voltage for 240 input. I have 260 output on this. So the theory tells me that if I move the blue wire to this post, this is the correct input for 240 volts on this transformer. Of course, if I measure between the blue and the red, I should measure about 20 volts. I just do the test to show you how it works. Between these 2 posts with the power on, I have a bit more than 20 volts, 22 volts. So by moving the blue wire to this other post where the red clip is now connected, we'll wire this primary correctly for 240 volt input. Okay, before moving the blue wire, I want to demonstrate why I always do this on these old drives with linear regulators, or even computers with linear regulators. On these two big capacitors, we have the input voltage of the 2 linear regulators. This one is a 12 volt 3 ampere regulator, and this is a 5 volt 3 ampere regulator. Of course, they are not supplying 3 ampere, neither of them on this port, more like less than 1 ampere anyway. But let's power on. This is the input voltage on the 12 volt regulator. Power on, and we have 19 volts, well, 21 volts when the motor stops, which is normal because there is no current consumption on the 12 volts when the motor is off. And let's measure on the other electrolytic now. Okay, here is the input to the 5 volt regulator, which is always powering the electronics regardless of the motor, and we have almost 13 volts. Keep in mind that the difference between 13 volts and 5 volts is dissipated in heat on this regulator, and also the difference between 20 volts, about 20 volts and 12 volts is dissipated here. They are very close. This gets very hot during the work of this drive. So let's see the difference when I move the blue wire. Okay, the blue wire has been removed from the central post and soldered to this one where the red crocodile is connected. And if we power on, we should read always the 230 and 2038 volts. Which is the main voltage tonight. But if we move the crocodile to the central post this time, we have 218, which is a bit less than 220. So now the transformer is wired correctly because the 240 inputs is connected to the mains input, and the 220 post is free because we have almost 240 volts anyway here. So let's repeat the measurement in the DC input to the regulators and see what changed. Okay, 12 volt regulator output input, I mean, it was 19 volts with the motor running and about 21 with the motor stopped. Now we have 17 and 19. We measured the input to the 5 volt regulators. It was almost 13 volts and it is now less than 12, which is good because even if it's only 1 ampere, which probably is even less, but it's already almost 2 watts less heat dissipated here, a bit more here between because we went from 19 to 17, so they run cooler. As a final step, when I modify a piece of equipment, I just add a little sticker to indicate that the input voltage requirements are somewhat different than the original ones. That would help me remembering what I did and help others that should have this equipment for sale or something. So it's always a good measure to indicate what type of work has been done or modification anyway. Okay, now I removed the drive from the chassis to clean the bottom side of the drive from smoke residues, also this part. And while we are at it, I can test if the spindle is running at the correct speed. But to do that, I need to use only an old magnetic ballast fluorescent lamp. The central images is for 50 Hz and it appears quite still, so the speed is correct. Good. So I decided I will not remove the front part of the mechanics just to be painted, because I don't want to disassemble much of this part. So I will mask off everything with paper and mask these parts that don't need to be painted. And also an important thing I will do is, starting from my old dry protection cardboard, that's original one when I got my 1541. I will make using this as template. I will make another one with another piece of thin cardboard to be inserted here, close the door. That will prevent most of the paint to reach the inside of the drive, where it would not be a good thing. So it's not to prevent the head from moving, but just to prevent the paint to enter the actual mechanic. Okay, here's my reproduction. Looks enough similar, and of course it works enough, but I think there's too much space here. So what I would do is to use mask tape in this position to try to close the space as much as possible, and also here. But cardboard is still useful because it would protect the head and the top pressure. In the end, I decided to mask everything but just the door lever, because I didn't find how many shade of white that is really suitable. This is a test template I made on a dark object too, with different colors. This is way too bright. With the colors I had home, well, because I didn't feel like just going around finding the right color for only this little piece of 1541C, which is working fine anyway, so it's just a aesthetical problem. So I will spray only the lever, which will result in a slightly different color from the rest of the drive, but I think it's better than the black part that show it. Anyway, this is a black drive, a black 1541 that has transplanted and painted, probably by Commodore itself, I don't know, or the previous owner of this drive just break the original drive front and replace it with this one, I don't know. Anyway, so this is the light ivory that I have, and I will spray with that, and we'll see after it cures what is the result. Okay, here's the result after removing the mask. Well, obviously different color, but I still believe it's better than leaving it with the black spot. Smooth and nice, so I like it better than the black spot anyway. Okay, so far so good. The disc mechanism works very well, both in write and read. Just played a few demos, including the X2018 from Performers, which is one of my favorite demos, and try to bend back the metal strip, but it was badly hit here. Also the case was broken, so it was a big hit, so I tried to glue back the pieces, but there's not much to do on this damage. Well, okay, the last issue with this drive is this hole that was drilled by some of the original owner to add this switch to select the normal disk operating system or the Dolphin DOS operating system ROM. Now it's a spare hole for me, and there are a few options to use this hole. I could add a reset switch, well, reset button actually, but reset button is easily added on the serial bus with a connector like this and a push button. This is funny, but it was my original reset switch in the 80s, and well, it just worked. So what I can add is little switch like this one, and connect this switch to this pad, this jumper J1 that can select between the unit 8 and 9 depending on the position of the switch, of course. When this J1 is jumpered like now, it is device 8. When booting, if it is open, it would be device 9 after reset or power on. So remove this solder from the pads of J1. Normally this is jumpered with a little track, as you can see on J2, but someone had cut the J1 at one time, then bridged it again with solder, so I just removed completely the solder that was bridging this J1. Then I can solder two jumper wires to bring these two pads to the switch that will be in the hole here. So now with the switch down, the unit is number 8, so I can load the directory with the number 8. Then if I flip the switch up, either reset the Commodore 64 or let's power cycle the Commodore, or connect a reset button and just reset the drive. Then the device will be on 9, so I can load the directory from device 9 just fine like before. So now I just have to close this 1541C and will be okay. I will try to load some demos just to be sure it's working well, format disk and so on, but it's okay now, much better than before. So thank you for watching.